Welcome to another session on data engineering. We'll quickly recap what we discussed in our last session. We said that the core of any data science project is to train and test a model. And there are three primary steps here. One is how do you pre-process the data? Pre-processing essentially involves things like treating missing values, treating outliers, treating multicollinearity, essentially making the data ready for the model to get trained. After you get the model data to get ready for getting the model trained on the data, you have the model trained on the data. And once the model gets trained on the data, you test the model and you check the accuracy of the model. And this is the core of the data science activity. However, while this is the core, this is not the one that consumes the maximum amount of effort and time. One of the largest chunks of the effort and time goes in making the data ready so that it can be pre-processed. Why it is so? Because we have data coming in various formats that can be a transactional data, that can be a digital media data, that can be a machine generated data, these data are usually quite big. They can be both structured and unstructured. The schema is unknown. So first, you have to dump the data in a place which we call as a data lake. But the data from the data lake cannot be pushed to the pipeline for pre-processing. We have to perform an operation called ELT, extract, loading, and transform, before the data can be put for pre-processing. This entire part is the data engineering part, which constitutes a substantial part of the effort involved in a data science project. Now the question comes, what happens after you have trained the model? Now let us look at from the user's perspective. Till now, we have not brought in the user. Let's take a problem like predicting customer churn. Who is the user of a model? Maybe a sales executive or a customer relationship manager who wants to know whether a customer is going to churn or not. So let us see how he or she can use this model to do that. Customer service executive now wants to know whether a particular customer is going to churn or not. So what does he or she need? He or she needs an interface. Usually there's a web or an app interface. On that interface, he or she is going to provide some inputs. The same inputs which are used as features while building the model. For example, how recent the customer has made a purchase, what is the frequency in which the customer is purchasing, what is the monetary value of the, the products that the customer is buying, and there may be many other features. Okay, what is the age of all the features essentially that has gone into training the model to predict whether a customer will churn or not churn. So all these features, the customer service executive is going to input on a web interface. Sometimes instead of a web interface, This can also be an application where the customer service executive will upload a file, which is a list of attributes for different customers. And what is the output that this customer service executive is expecting? The customer service executive is expecting an output where once the customer presses a button like predict, he or she is expecting an output which will say whether a customer will churn or not churn. This is what the expectation of the user is. But now the problem is that how will this data, which is the features, interact with the model sitting over here and get the prediction and show the output over here? There are two challenges. First challenge is this data is on a web interface. Web interface data has to be made compatible, or the data collected on a web interface has to be made compatible with the environment where the model is residing. Who will provide that? There has to be a service which is called the web service, which will take this data, web data, the input, and convert it in a format that can be used by the model. But then that's not good enough. When we train the model, the data went through some pre-processing, like missing values, outlier detection, multi-collinearity check, etc., etc. Now, the data that is input over here may have the same problem. For example, it may also have missing values. It may also have outliers. Now, if the same treatment is not given to this particular input data, then the model will not work on this data because the model is trained to work on a data that is already pre-processed. So that means the same set of pre-processing has to happen on this model as well. Okay. So let me just put the element in the other side. The same set of pre-processing, maybe we'll take a different color. Same set of pre-processing has to happen on this data. Now, how do we ensure that the same set of pre-processing is done? There are two ways. We write exactly the same program in this environment again. But what is the problem there? The problem is two. One is double effort. We have to write the program again. But the bigger problem is that it may not be always possible to keep these two programs in sync. Okay. So something else needs to be done. What is the something else? The program that, or the set of programs that did the pre-processing, they should be packaged into one object which will do the same pre-processing on this data as is done on the original data that was used for training. You can think of it like an exe file, executable file. When you install a Microsoft Office or a Microsoft Excel, you execute a file, okay, which has a condensed set of code that will install Excel on your environment. In the same way, this should be transported in the form where a simple executable file-like thing will work on this data and do the same pre-processing and give the same output as it was done with the original program. So let's say we have solved that problem. We have got this pre-processed data. But then the question is that now the pre-processed data has to go through the trained model and has to give the output. Now, this cannot happen in this environment because this environment is a development environment. And there can be changes happening on this environment, and it is not recommended that this data goes through the same model in this environment. So we have to transfer the model just like we transfer the pre-processing. Similarly, we have to transfer the model in another environment similar to an executable file So what is a model? Essentially, the output of the trained, when we build the model, the output was either a mathematical condition, like an if-else kind of condition in case we are using decision tree, or it can be an equation if we are using a logistic regression or a neural network. Okay. So whatever be the condition, whether the equation or an if-else condition, is a mathematical logic. Now, this mathematical logic again can be built in a separate environment, but as I said, that's not a recommended process because then these two things may not be in sync. So again, the best part is to transport this in a similar mode, like an executable file, into a new environment where this pre-processed data, which has now gone through the pre-processing, same pre-processing steps as this one, will be fed and the output will be generated over here. So this is the model which has been transported into a new environment, and this particular point where the model is residing is called an endpoint. And now we have this entire thing in a particular environment, which is a production environment, as opposed to the previous environment, which we can call as the development environment. Now, this process of moving all the pieces of code that has pre-processed the data as well as the model, that particular activity is called model deployment. So now you can see the core part which is happening, which is the model development, which is the core of data science. This constitutes maybe 10 to 20% of the activities. Whereas the remaining 80% of the activities are in this. So, and within that, there can be probably 50% over here, and maybe 30% effort goes over here. Of course, it varies from nature of the problem or not. So if you look at the entire activity of a data science project, all these three components have to be there. And as I said, that the data engineering component, most of the companies today are moving to the cloud environment because the data is huge and developing these ETL components bottom up is a very complex task. On the other hand, most of the cloud environments have different components already built in, which can be assembled to build this ELT pipeline. This is called platform as a service. Now, once this is done on cloud, obviously it's much more convenient to have the model development also in the cloud and the model deployment also in the cloud, because then you can have one environment where all of these things can be seamlessly integrated. So that's why more and more companies are moving this entire set of three pieces into the cloud environment. And that is why the data engineering and model deployment, sometimes that's why it is also called data engineering and model deployment. Many courses are named like that, data engineering and model deployment. This mostly is occurring on the cloud. And that's why knowing how to do this entire pipeline on the cloud, the end-to-end, becomes very, very important skill in today's scenario.